Welcome back after a long gap. So today our topic is laws of indices. Laws of indices. You know, if we multiply a number repeatedly by itself, like something like this, we are multiplying 2 4 times. This can be expressed in an exponential form or power notation. If we multiply a number by itself repeatedly, then it can be expressed in exponential or power notation. How? It is multiplied 4 times, so we can write it 2 to the power 4. That means 2 is multiplied 4 times. This form is called exponential form or power form. And in this exponential form, this 2 is called the base and this is called power or index. Okay? This is called the base and this is power or index. Clear? Now, if we use this term for a negative number, say it is n, minus 1 to the power n, or say minus 5 to the power n, whatever it be, if a negative number with exponent n, it can be even, it can be odd, isn't it? It can be 3, 7, 5, 9, it can be 2, 4, whatever. So if you consider this power as even, for example, minus 5 square, so it is nothing but, and minus minus it becomes plus. But if the power is odd, then what happens? Minus minus plus again into minus, the final sign is minus. So you see that if the power is even, minus becomes plus. If the power is odd, minus remains minus. So a negative power, a negative number raised to an even power is positive, but a negative number raised to an odd power is negative. Okay, this can also be applied for fractions. Suppose like this, 2 by 5 whole square. Two into 2 by 5 into 5. So the answer is 4 by 25. An important observation is P by Q whole to the power n can easily be written as P to the power n by Q to the power n. Got it? The numerator denominator is separated and power is applied to both numerator and denominator. Clear? This is an important observation. Similarly, if P into Q whole to the power n, you can write it. Got it? P to the power n into Q to the power n. But remember, P plus Q to the power n is not equal to P to the power n plus Q to the power n. Very important. Many students are stuck at this point and write it like this. But you should remember P plus Q or minus P minus Q to the power n is not equal to P to the power n plus or minus Q to the power n. So these are three very important observations during your index problems. Clear? Okay. So we have understood the term base and power. One simple example. Do it yourself. 16 by 81. This is written in rational form, isn't it? What is rational form? What is rational number? What is rational number? Any number which can be expressed in form P by Q, where Q is not equal to 0, is called a rational number. Here P is 16, Q is 81. Okay? So this is rational form. The question is, express this number in exponent form. Very common question for class 7 and 8 students. Conversion between rational form and exponent form. What will you do? Prime factorization method. Prime factorization. What is that? You factorize the numerator, you factorize the denominator. What will you get? 16, 8, 4, 2, 81, 3, 3, 3. Okay? So 16 can be written as 2 into 2 into 2 into 2, 81, 3 into 3 into 3 into 3. So it is 2 to the power 4, it is 3 to the power 4. Okay? So if we replace this 16 by 81 with 2 to the power 4 and 3 to the power 4, you can see power is 4 in numerator and power is 4 again in denominator. So remember that one, P by Q to the power m equals to P to the power m by Q to the power m. Just the reverse, we can write it as 2 by 3 whole to the power 4. This is the rational form and this is the exponential form. The question can also be reversed. You can be given an exponent form and can be asked to convert it to rational form. Okay. So if you get the power same in both the numerator and denominator, it is easier. But sometimes you may not get the same power after your factorization. For example, say 343 by 1000. Seven, 28, 6. Okay, so 343 equals to 7 into 7 into 7. 1000 prime factorization 2, 502, 252, 125, 5, 25, 5, 5. So 1000 is 2 into 2 into 2 into 5 into 5 into 5. Now you see, the numerator can be written as 7 cube and the denominator is, this one is 2 cube, this one is 5 cube. So if you are to maintain the power 3, you have to club these 2 and 5, isn't it? 7 cube, 7 to the power 3, 2 cube into 5 cube. So here 7 cube, 2 into 5 cube, that is 7 cube by 10 cube. So finally 7 by 10 cube. This is your answer. Now this rational number is expressed in exponential form. Okay. So these are the way of solving this type of problem. There may be a problem like this, the negative sign. Suppose minus 27 by 343. This minus sign indicates that this should be in exponential form with power an odd number, because the minus is maintained. So power must be odd number to maintain this negative sign. Okay, process is same. 27, 3, 9, 3, 3, 343, just done in the previous problem. 7, 49, 7, 7. So it is minus 3 into 3 into 3 by 7 into 7 into 7. So minus 3 cube, 7 cube, minus 3 by 7 whole cube. This is the exponential form. Got it? Okay. So you can solve this type of problems where rational form is to be transferred to exponential form or the reverse one. Okay. Next thing to learn is, if we get, suppose 2 square, that is 4, 2 cube, 8. Now if you are asked to multiply 2 square with 2 cube, that is 4 into 8, 32. If you factorize 32, what will you get? 1, 2, 3, 4, 5. 2 to the power 5. So you see, it is nothing but addition of the powers. They are added. Okay? So the conclusion is x to the power m into x to the power n, where x is the base, same base, different power m and n. The result is x to the power m plus n. Very important rule or law of indices. First law of indices. X to the power m into x to the power n equals to x to the power m plus n. First law. Second law is similar, only the sign is x to the power m divided by x to the power n. The power is subtracted, minus x to the power m divided x to the power n equals to x to the power m minus n. Second law. Third law is x to the power m whole to the power n is x to the power m into n. X to the power m whole to the power n equals to x to the power m into n. These three laws are very important and you have to remember these three laws very carefully. Another important law is anything to the power 0 is 1. Why? Suppose you consider is 3 minus 3. It is 0. Now according to this second law, you reverse it. X to the power m minus n equals to x to the power m by x to the power n. So here m is 3, n is 3. Same number divided 1. Got it? So this is your fourth law. Anything to the power 0 equals to 1. These fundamental laws are used for simplification problems. I am giving one example. Suppose three by 4 to the power 5 into 4 by 3 to the power 2. What is the similarity between 3 by 4 and 4 by 3? It is a reciprocal. If a number is altered upside down, this is called the reciprocal of this and this is reciprocal of this. Okay? P to the power m if reciprocal of p is 1 by p, it can be expressed as p to the power m equals to 1 by p to the power minus m. The reciprocal will have same power with negative sign. The reciprocal will have same power with negative sign 2 to the power minus 1 is nothing but half to the power 1. 2 to the power minus 5 is half to the power 5. See, the reciprocal of 2 is half, 1 by 2. Power is same with negative sign. Minus of minus 5 becomes plus 5. Got it? Very important. Reciprocal of the number will bear same power with negative sign. Okay. So come to the problem. If we change it with its reciprocal, we can write like this: same power with negative sign. Okay? And x to the power m into x to the power n log m plus n. This is the simplification. I am providing a sheet in the comment box with some problems for class 7 and class 8 students. Another video will follow which will deal with laws of indices advanced for class 9, 10 and 11 students. So you go through my problem set 1 in the comment box, do it, send it back to me, and after that, if you get interest, you can also follow the next video, that is laws of indices advanced. Thank you.